If you want to build real-time updates into your React application, like chat, in-app notifications, live graphs, feeds, or maps, or even multiplayer collaboration features like online presence and real-time cursors, WebSockets are your best friend. In this video, you're going to learn all about WebSockets as we build out a smooth live cursor experience using React on the front end and Node on the back end. Here, the idea is to show you the fundamentals and some React WebSocket best practices. You might be building a live cursor application, but I want the lessons in this video to apply to various projects no matter what shape they might take. We'll jump into things in just a second where we're going to solve some really interesting challenges around how to manage the WebSocket connection, but also how to efficiently deliver frequent real-time updates like live cursors moving on the screen. But first, let's take a quick look at the fundamentals. It might sound a little bit counterintuitive, but to understand WebSockets really well, it's going to help to take a quick look at HTTP. Hi, I'm Alex Booker with Ably, the Real-Time Experience Infrastructure API. Let's get into it. Okay, so HTTP, we know it, we use it, we love it. It's the foundation of the modern web, and it's the protocol we most commonly reach for when we think about sending or receiving data between a front-end client and a back-end server. With HTTP, the client sends a request to the server, and then the server sends a response. We call this the request response model, and it works really well when you know you want to fetch or send data based on a specific client event. So for example, if you have a feed and a load more button at the bottom, when the user clicks that, that's a client event, and you can then send off the request. Nothing wrong with HTTP. I'll be using it in my next project, but where this request response model kind of falls down is in situations where the client doesn't yet know when there's going to be an update available from the server. For example, say you're building in-app notifications. The client will have no way of knowing when there's a new notification available on the server, and therefore it has no timely trigger to send off a request for that information. You have to remember that with HTTP and this request response model, the server has no way of initiating a data transfer to the client. It just has to sit there and wait until spoken to. You could say that this is an example of a one-way or unidirectional type of communication, but what we need often for real-time features is two-way or bidirectional communication. We need a way for the server to be able to push fresh data as soon as it's available, instead of just idling and waiting until spoken to. This is exactly where WebSockets come into play. With WebSockets, a two-way connection is established, allowing either the client or the server to send fresh data as soon as it's available. It could be the client sending data based on a client event, or it could be the server saying, hey, I've got a new chat message for you, or a new in-app notification, or a new data point to render on the graph. WebSockets do have a kind of gnarly spec, and we ourselves at Ably have written a whole book on the subject. But you know what? For the purposes of this video, there's just 3 things you need to know. Number 1, under the hood, WebSockets establish a long-lived connection. This is very different from HTTP, where an ephemeral connection is opened for the request and response pair. By opening a long-lived connection in this way, WebSockets can reduce the overhead of having to navigate opening and closing a connection every time you want to do a data transfer, making them really appropriate for high-frequency updates. Number 2, once the connection is established, either side can send fresh data at will. It can be binary data, or it can be text-based data like JSON. And the really cool thing about WebSockets is that they are full duplex, which means the server and the client can both send information to each other, don't know what this is, simultaneously improving the throughput of information. Finally, I want you to understand that WebSockets are a totally separate protocol from HTTP, but they are not mutually exclusive. In fact, it's very common and encouraged to use both in the same application. It's not a case of picking either or, it's more about picking the right tool for the job. So I don't want you to think that you have to use WebSockets for everything in your application. You will probably still use things like HTTP for authentication and typical sort of post requests and things like that. But then you'll bring in WebSockets as the right tool for the job when you want to send real-time updates. Going back to that example with in-app notifications, well, once the web connection is established, the server can just send over that update whenever it's ready in a very efficient way. The in-app notification example is actually kind of interesting because it's an example where the server is more chatty than the client. In this case, the client is kind of waiting for an update from the server. But WebSockets are especially fantastic and uniquely suited for situations where both the client and the server are pretty chatty. It could be a chat application, but to bring this a little bit closer to what we're going to be building step by step today, it's also really perfect for something like live cursors, where we are going to be sending our cursor position every time the mouse moves. And at the same time, the server is going to be broadcasting everybody else's mouse position as soon as it knows about them, as soon as it gets the latest updates. And because WebSockets are full duplex, all this information is going to flow across the channel in a very efficient way. Next up, let's bring that vision to life. We're going to build this smooth live cursor experience, and we're going to give some very careful consideration to the performance implications. I'm gonna switch angle, share my screen, and relax. Feel free to follow along and type along. We'll be doing this step by step, but if you prefer, you can check out the code on GitHub or read the written version of this tutorial over on the Ably blog, and then just watch the video to see it evolve step by step, basically. First up, let's take a look at what we will be building. The user is going to be able to log in, and watch how when I move my cursor, there's a red cursor rendered beneath. If I open another window and log in, we can see the cursor location is visible to everyone, creating a visual cue about where the other users are and what they're doing. It's like what you might find in a tool like Figma, Miro, or Framer, and it's pretty cool. Additionally, you can see a crude list of who's online. I included this because once the foundation was in place, it was so easy, I thought, why not? But obviously you'd want to make it look pretty. As a very quick side note, at Ably, we have a product called Spaces that helps you enable collaborative environments in your own apps, including cursors. This tutorial doesn't use Ably, it's entirely raw WebSockets. But because there are these live cursors, you can actually check out the interactive demo and borrow the CSS. It's all open source and you're welcome to do so. And the same with avatar stacks, so check that out if you want to make them look pretty. And who knows, maybe you'll check out Spaces and realize it's pretty perfect for your production project. Here though, we're using raw WebSockets, and we're doing cursors not because it has anything to do with Ably, but because they're a pretty perfect way to demonstrate and teach how to use WebSockets, because they are bidirectional, and live cursors in particular are quite demanding because of how much information is flowing back and forth over the same channel. You can see that the cursor is slightly animated. This delay isn't so much a lag and it doesn't look jumpy. This is something you're going to learn how to implement later in the tutorial. We'll be building this project in 2 steps, 1 step for the server and 1 step for the client, and we'll do it in that order because the client can't really do much until it has a server to connect to. Let's start building up the server step by step. Our server-side WebSockets adventure begins in an empty terminal where we're going to make a new directory for our project and call it Live Cursors App. Inside this directory, we're going to make another called Server and navigate into it. Later on, we'll create a separate folder for the client to keep things nice and organized. Making sure you're inside this server subfolder, run npm init with the Y option. That just says yes to all of the options, saving us some time. And let's also install the WebSocket node module and another module called UUID, which stands for Universally Unique Identifier. Node does not have a built-in WebSocket module, so we import the closest thing to an official one we have, which is WS. It's been around for a long time now, as well as this kind of helper module, which can be used to generate unique identifiers. For example, it will look something like this, but with numbers and different letters in order to help us uniquely identify a connection. We'll get into that soon. Next, we're going to create a file called index.js, but we're going to do this outside of the terminal. Let's do it in VS Code. And just with a little bit of foresight, we're going to navigate back up into the root of the project folder and open that in VS Code, because later when we create the client folder adjacent to server, we'll be able to see it and work all from the same place. So inside of server, where we now have our package.json file and the relevant npm modules, we're going to create a new file called index.js. This is going to be the primary script and entry point for our server application. Okay, I promised we would do this step by step, so here we go. Step 1, let's create the WebSocket server. Now, bear with me here because the first step to create a WebSocket server in Node is to create a HTTP server. The reason why we do this, and it's pretty handy, we've written so much about WebSockets on the Ably blog before because we have lots of helpful diagrams to help illustrate this. It's just that the way that a WebSocket connection is established is by performing a handshake over HTTP. So our server must need a way to speak HTTP, hence we create the HTTP server first. I will link that post in the description if you want to learn more. Next, however, we can create a WebSocket server by importing the WS module. And we pass to this constructor an options property where one of the options is server, the HTTP server, but we can shorten this by using ES6 syntax like so. Let's make this file a little bit bigger. Nice. So at this point, we've instantiated both the HTTP server and the WebSocket server, but we're not yet actively listening for connections. The way we do this actually is by just listening on the HTTP server. And to this function, we pass the ports we want to listen to, as well as a callback function to run once the server is listening. Here, we're going to log a success message, and we'll say something like WebSocket server is running on port 8000. But to reduce a magic variable, we're going to put a constant for the port number and reference it like this. And we'll change the string to a template literal string. And then if we go to the terminal, just as a little sanity check here, and we cd into the server and we run node index.js, this should technically start the server and we'll see that it's running on port 8000. There we go, step 1 complete. Okay, step 2. Let's accept incoming connections from users, identify the user by their name. You'll remember during the demo, we asked them for their name. And then let's also keep track of those users and their underlying connection. That's going to be really handy to reference later on. It'll become clearer why as the tutorial progresses. You might have noticed that despite the fact that we were running the server, the WS server variable is not getting much action. Let's change that by calling WS server.on. And we'll say on a connection, this is a type of event. When this event happens, we would please like to call this callback function, which passes the connection and the request. As you now know, and with thanks to this diagram, a WebSocket connection does begin with a sort of HTTP request as part of the handshake, and that's what this argument here represents. This other argument connection is the underlying WebSocket connection, which we'll be able to use to, call things like send, for example, when we want to send message to a user at the other end of that connection. We'll get into that in just a second, but the first thing we want to do really is identify the user before we go any further. Now, the way we're going to do this ultimately, when we get to the client side, is when we connect to the WebSocket server. First of all, when you connect to a WebSocket server, you specify the protocol up front, which is WS or WSS if you're using the encrypted version, very similar to HTTP and HTTPS. So let's just say we're connecting with WS and we connect to localhost and we're running on, port 8000. So we'll connect on port 8000 just like this. The really cool thing is that even though this is technically a different protocol, we can still pass query parameters. Query parameters, if you've not come across them or you don't recognize them by name, it's essentially where you add a question mark at the end of the URL and then a parameter like username, where I can say Alex. And you can, by the way, add a bunch of these by using the ampersand, and you can look into that separately. In this case, we just need to know the username. So to summarize, when we connect from the client, we'll be connecting using a string like this, and we'll be passing the username entered into the text input via the query parameter. We now need a way to access and extract that on the server. The way we do this is by first importing the URL module. This comes directly from Node, by the way, so there's no need to npm install anything. And then we call url.parse, and then it wants to know the URL string, which is going to be accessible via that HTTP request argument. It's just a case of passing request.url. It asks us if we want to pass the query string, which we do. And if we pass true, that gives us access to the query property on the object returned by parse. And on that object is a dictionary that has a key for each query parameter, in this case, username. However, the way I like to express this in code is not by calling the .username here, but by doing it like this. The thing that's really fun and interesting about a tutorial like this is that generally we want to see things evolve step by step, but it wouldn't ordinarily be possible to see much of the server in action until we start building out the client with React. Fortunately, I have a way to show you and also test the code to make sure it's working before we go too far. Basically, with something like HTTP, I mean, because every website uses HTTP and it's the basis for a lot of websites and APIs, you can just, pass the URL into your browser, see the JSON it returns, whatever. You might even use a command line app like curl to post data to the server. You may also have come across an app like Postman, which can be used for HTTP requests, but really, really useful for our purposes here is that if we open Postman, which is kind of like a request inspector, request debugging development type tool where you can simulate requests without your own clients, if we press Command N, we can create a WebSocket connection. We'll type in the URL, which is going to be WS, this is the protocol part, the host, and then the port 8000. And we'll also supply the username here, making sure the server's running, and it is running, but we'll have to reload it obviously because we've made some changes. Let's just see if hopefully, and I'm jumping around a bit here, but I'm sure you can follow with. It's just that we extract the username and then we log it to the console. So in theory, when I press connect, this should connect to the server and the server should accept this username query parameter and log it. Let's see what happens. Oh my gosh, it worked. I shouldn't be so surprised, but this is fantastic to see. It means that we're off to a great start and we're well on our way to completing step number 2 here. Obviously, I said we want to identify the user. We've done that. The other thing we needed to do is track both the user and the connection. Now, to do this, we could, when you think about tracking users and keeping track of unique users, we could use the username as their unique identifier. But what would happen if 2 users with the same username happen to connect? It's not that likely to happen, and this is quite contrived. But since it's so easy to follow this best practice, we will. And that best practice is to generate a unique identifier for each connection and use that as their individual key or way to identify them. And the way we do this basically is by calling this function uuidv4, which we also have to implement or import, and that comes from the UUID module that we installed previously. It just so happens there's different versions of the UUID function and they're versioned this way. And the way you import it is by calling require UUID and then passing .v4. I don't want to go too far without double checking this. So I'm actually going to log both the username and the UUID. Going back to the terminal and reloading it and then reopening Postman, you can see that we have disconnected, so we should be fine to reconnect. You can see, hey, here's the username. And again, just for fun, let's say we change this to someone else's name and reconnect. You can see here that, for example, Chloe has connected and they have a completely different identifier. This is uniquely generated. Okay, with the unique identifier in place, we're at a good point to start keeping track of connections. And the way we're going to keep track of connections is by creating a connections dictionary. And then every time a new connection is established, we're going to create a new entry by using the uniquely generated identifier as the key, just like so. So every time a new connection is established, we're going to store it inside of the connections dictionary. The key is going to be that unique identifier. And the really great thing about this now is that, first of all, as long as we know the unique identifier, which we have our ways of referencing later, we can pull out a connection, maybe the one associated with the user, to send a direct message if that was a requirement, which it isn't in this case. What is a requirement, however, is that eventually we're going to want to do something called a broadcast. And a broadcast or a fan out is when you send a message to every connection, to every connected user. Because we have this dictionary now, it's not too far out of reach to enumerate that dictionary, or in other words, loop over it and just call connection.send, 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 and make sure that everyone connected gets a message. At the same time as keeping track of the connections, we're going to want to keep track of the users. Now, I understand this distinction might seem very subtle and nuanced, and it'll be hard to really understand until we see things evolve. But let me try my best by explaining that this connection object that we're getting passed with the connection event is a very kind of complex prototype with a bunch of functions on it, a bunch of metadata, and all that kind of stuff. We're really just keeping track of this connection so that we can later call connection.send in this way. However, in addition to being able to access the connection, we also want to keep track of the users behind that connection and associate some of our own kind of metadata with that user. For example, and let's just do this together and watch it unfold, we're going to want to create a new user every time a connection is established, and we're going to associate with that user their username. Now, I guess what we could do is affect and mess with the prototype a bit and start adding our own objects, but this creates two problems. First of all, it's a little bit fragile, especially in a complex app, because if you start messing with the prototype, then another function somewhere else in the code might not be expecting it or might overwrite it or something like that. I generally try and avoid this when possible. And also, by the way, in a moment, we're going to want to serialize, which is a fancy way of saying we want to call JSON.stringify for the user. And if we were to call something like this and JSON.stringify the connection, we're going to get a bunch of like random metadata through the connection we don't care about. Whereas if down here, we call JSON.stringify with just the user, we're only going to get this very focused, clean, tidy information without the need to trim it down or pass it on the client, for example. Now, in addition to the username, we're also going to want to create a state object to associate with the user. This is a really interesting concept in real-time applications, and it goes beyond just a live cursor application. So I'm initiating the user with an empty state object, and I'm frankly doing this as a way to illustrate what the shape of the object is going to be, and we can also use it now to give a few examples, because basically what we're going to do is we're going to create two properties like this, one for the cursor X and one for the cursor Y. And every time the user moves their cursor on the clients in the React app, we're going to send an update to the server over the WebSocket connection with the new X and Y positions. We're going to look up the user in this dictionary and we're going to update their X and Y values. Then every time there is an update, and frankly we could do this in other ways like in a timer for instance, but essentially we're going to want to periodically send a broadcast to all of the connected clients with a list of connected users and their cursor position, or in other words, their associated state. We could, if we wanted to, just make the X and Y part of the user. And for this application, that's pretty valid. But the cool thing about thinking about state in this way, and another way of thinking about it, or another word for it is user presence, is that we can associate any kind of metadata really with the user that we expect could be updated in real time. For example, if you're building a chat application with WebSockets, another type of use case that WebSockets are really quite perfect for, you might have a typing Boolean like this to say they are typing or not typing. You might also, in either a chat app, but also a collaborative app, you might have like an online status property, which could, yes, it could be something like online or offline. That might not be necessary just due to the fact the connection's either there or not, but it could be something more like out for lunch or, in a Zoom meeting, for instance. We can associate any information with this client or with this user, and the idea is that if it updates, then that update should be reflected in all the clients immediately without the need for the user to reload the page. Now, I've just thrown a lot at you. I'm going to undo some of this illustrative stuff and just keep it nice and simple. We're creating a user with their username, and we can simplify this further. And we're creating a state object where we can associate the X and Y position, but also maybe in the future something else as well, whether that's an online status in the collaboration app, or maybe your app, maybe you're not building live cursors, maybe you're using this as the foundation for something else. This is a very versatile pattern. But despite my throwing quite a few things at the wall just now, don't worry if it doesn't entirely make sense. This, at least for me, is the kind of thing that only makes sense when I see it unfold. And that's the exact reason we're doing this step-by-step, to see how it plays out in a step-by-step fashion. The next thing we're going to do with access to the connection is wire up some event handlers for the connection itself. So we have an event handler on the WebSocket server that says, hey, every time there's a new connection, we want to run this code. Here's a reference to the connection. But now we want to say, okay, on that connection, on a message occurring, do this. And on that connection, if it closes, do that. Let's wire this up step by step. Basically, when we get a message, we get passed the message, and we're going to pass that to a function we haven't yet created called handle message. And what we're going to do here is pretty clever, I think, because in addition to passing the message, which is available as an argument here, we're also going to pass the UUID. This is a way of capturing the value of the variable so that every time we get a new message, we'll know who it is and the identifier of both the connection and the user. That will allow us to look up those respective values if we need to and alter them. Again, we'll implement this handle message function in just a moment, but I'm choosing to do everything down here at the same time, where if the connection is closed, we're going to call a function called handle close, and we're going to pass the unique identifier as well. This will be handy so that we can, for example, remove or delete the entries from the connections and users dictionaries. While I'm up here, let's create the event handlers themselves. Okay, with the event handlers declared and wired up, we can move on to implementing each respective event handler. Maybe we'll call handling messages step number 3. I know I just mentioned this, but as a quick reminder, because it's so important to understand what we're doing here, more or less every time the user moves the cursor in the React application, the React application is going to send a message to the server with that user's X and Y coordinates, with the cursor X and Y coordinates. Probably the message is going to take a JSON format and it's going to look something like this with an X and Y position like so. What we want to do in this handle message function is take the whole message. This is what the whole message is going to look like. So the client is going to send a message and it's going to look exactly like this. We're going to want to take that message and look up the user and basically update that user's state. Say we have access to the user, we could say user.state.x equals whatever. We can say user.state.y equals, whatever, like this. But I'm just going to tell you right now that because this application is so focused on cursors, we're probably going to be able to just do this and overwrite the user's state with the message. Remember, the state is separate from the username, so we won't be affecting the username. The user.username is still going to be there. What we're doing every time we get a message is the message is going to be the state. And so the object will look like this. We're going to copy it and we're going to replace the state, something like this, just to give you some context about what we're trying to do here. Again, I'm taking a moment to explain it the best I can because it's quite hard to understand unless we can visualize it in some way, but without the client application, that isn't possible. Let me clear up all this craft and explain something else, which is that the way WebSockets work is that even though we're wanting to send JSON, we're wanting to send a string, which is JSON like this, what we get on the server are bytes. So the first thing we have to do is call bytes.toString to convert the bytes to a string, go figure, and then we want to convert that string into an actual object. And the way we do that is by calling JSON.parse and passing in those bytes. What we get in return is the actual message. You know what? I'm going to illustrate this right now. Let me print out the message like so, go back to the terminal, rerun the server, applying all those updates we've made. Here in Postman, our favorite tool of the day, we're going to clear the messages and reconnect. This time is Chloe. So as you can see, Chloe connected. Here's that unique identifier. Now here's the cool thing about Postman. You can actually choose a format like JSON and send a message. And as it happens, I did remove it because I'm too eager, but we'll copy more or less this exact same message and paste it in here. What I'm hoping to see is that when we press send, this handle message function is going to run, it's going to pass the message and log it. Let's see what happens. And just like that, you can see the message printed into the console. And just to illustrate that there are no smoke or mirrors, we can update the value here and see it updated. And this is actually the closest thing we've had to a realistic client so far, because imagine someone can, in fact, let's just go from scratch. Let's say that Madeline connects right here and they've connected as a user via the React application. Their cursor is probably going to start in the top left, but every time they move the cursor, just like this, I'm pressing Command Enter to send the position with Postman, you can see that the server is receiving the new cursor position. And this is fantastic because it's happening over the WebSocket connection without the need to do a post request. And as you will see in a moment when we get across to the client side of things, it will be possible for the client to subscribe to everybody else's cursor position, receive those cursor positions, and render them some way on the canvas. With the message now accessible to us, we have everything we need to actually look up the user, because we have the UUID right here to look them up. It's as simple as going const user equals users, and then we pass the key, which is the unique identifier here, and then we literally say user.state equals message. And again, as a quick reminder, I think it's worth reiterating, we could do something like this, message.x, but because we're only expecting a very specific shape of message here, we can do this in the tutorial. Probably, definitely in another type of application, you would want to maybe have like an if statement and check if the message type is equal to cursor update, do this. If it's equal to chat message, do that. But again, this is contrived, so we have a privilege, which is that we can assume things are a certain way and work a bit more efficiently here. I'm going to call that step 3. Step 4 is a really, really interesting one because so far we've accepted connections, we've accepted incoming messages, but what we haven't yet done is send a message to the client. And actually that's the whole point of WebSockets, right? That the server can push fresh information as soon as it's available. There are lots of different models and patterns for sending data from a server to a client. Basically, it could be one-to-one, like in a chat message, or maybe you're showing a progress indicator to a specific user based on their action. That would be sending a one-to-one type of message to a very specific recipient. There could be one-to-many, for example, where the server is sending a message to a group of specific users. For example, those in a group chat or those looking at a specific page, like a live sports score update or a live graph, for example. And then there's another type of one-to-many interaction where you send it to every single connected client. And as you now know, we call that a broadcast. And that's the model we're choosing to use for this type of application. So I'm going to create a function called broadcast like so. Now, don't be alarmed if you see that I'm not accepting an argument. It would be pretty natural to accept some kind of message or data that we expect to broadcast. But in this case, the way we're going to do this, the way this real-time application is going to work, is that every time the server receives a message, which we know is going to be a new cursor position from any connected client, what we're going to do is we're going to broadcast that list of users to everyone who's interested. In other words, every connected user. This is fantastic because it shows who's online and their associated states. And part of that state, of course, is their username and their X and Y coordinates. This means that the trigger for everybody receiving an update is instantaneous. As soon as there's an update available, we're going to broadcast the server's view of state to every client where the cursor can be updated on the screen immediately. And again, just to be clear, the benefit of WebSockets here is that we're getting that fresh information without the need for the client to reload the page. That's the essence. It's great for live cursors, but you could see this being really handy for a notification or for a chat app or something like that as well. So step 4, implementing the broadcast function. There's not too much to it, really. The way we're going to do this, and there are a few different ways you can enumerate a dictionary in JavaScript, but we're going to call object.keys. This returns an array, I believe, of all of the keys, which are going to be the unique identifiers. Once we have that array of keys, we're going to call the for-each function on that array, and each object is represented by the key, which is the unique identifier, so we'll represent it like this. And here is the function and the code we're going to run for every single connection. First of all, we're going to want to pull out that specific connection by referencing it via the UUID, like so. And as I hinted to previously, this allows us to call connection.send. What are we sending? Well, we're sending a message, and that message is going to be the stringified version of users. And we send it like so. The only thing left to do to complete step 4, and it really is quite straightforward once you get the framework in place, you can really start to move quite quickly here. The idea is that every time we receive a new state update or a new X and Y coordinates, we update the user's array, or the user's dictionary, I should say, and then we broadcast the users to everybody. And if I was being really good here, I might honestly call this something like broadcast users, but this app is so simple, we can infer it from context, I think. Listen, we've written a few lines of code. We haven't tested it, but we've got Postman to hand to see if we can make things work. So what I'm going to do is rerun the server, reopen Postman and just, clear the messages and clean things up a little bit. I'm going to connect as Madeline again. Now, here's what I'm expecting. I'm expecting that when I send the X and Y cursor position to the server, it's going to update its internal view of state via this user's dictionary, and then it's going to broadcast that user's dictionary in JSON format to every connected client. Now, in this case, I am the only connected client, so I'm expecting a bit of like an echo effect where when I send the updates, the server is going to send me back what it sees. So let's have a look. I press send. And check it out, the up arrow means we uploaded or sent the X and Y coordinates, and what we get back from the server looks something like this. This is Madeline's unique identifier, their username, and their associated state. Remember, the idea is that as the cursor moves, maybe they make a big move in the X position here and sends it. When this message gets sent, it should basically be this one. It should replace the state entirely. So let's minimize that, press send. You can see we upload what you saw in the message text input here, and what we get back is that new value. I love Postman. I really love that you can open a new tab like this. You can literally see all your previous URLs and reconnect just like this. And now both clients are connected, by the way. And while it's not the best visibility in the log here, you can see that Chloe's connected and previously it was Madeline. They're both connected at this point. And this is very illustrative because right now, Chloe has not sent any update. Just imagine these were two separate web browsers, both running React applications. Madeline just moved. I'm starting to get really excited. I sound like an F1 commentator. But if Madeline sends her Y position like this, yes, we get that kind of echo effect, but crucially, this is really important. Now Chloe is receiving these updates, and you can see that actually they don't have any state yet. That's fair enough. We should check for that in the client code, is not to make a faux pas, but crucially, we can see Madeline's most up-to-date cursor position. And just for fun, you remember how I was like, pressing Command Enter a lot to, keep updating. What you see now when I switch back to the tab with Chloe is just a stream of updates, accessible, immediately available. Once we get around to the client application, we can access all this in JavaScript. It might not be so hard to then take this data to render a cursor on the canvas. The one thing we haven't done, and this is pretty much the final step for the client, or for the server, is implement the handle close function. Fortunately, it's not too hard. The idea here is that when the connection closes, we want to delete the user and the connection from our dictionaries respectively. And because we have access to this UUID, it's really quite simple. We say const connection equals connections, and then we reference the connection. We do the same with the user like this. And then we call, well, I was going to call delete on the variables, but I think it makes more sense to do it like this, actually. We just use the delete keyword to remove the reference to those objects. It's really that simple. And because we have that handy broadcast function, we're going to use it. Why? Because, well, now every time one client disconnects, the server is going to broadcast the most up-to-date version of the user's object in particular, so that the client can kind of figure out that someone disconnected, because they won't be part of the users anymore. They'll receive the most up-to-date version of the data. In a more like realistic production app, what I would probably implore you to do is like send a specific message that says user gone, and then, say I went and disconnected, tell the client who disconnected. That'll make it easier to sort of remove them from a who's online list, or, by the way, when it comes to the who's online list, I just showed a very simple example where they're either there or they're not. But in an ideal world, and, at Spaces, we thought a lot about this, you probably want to show, oh my gosh, I'm getting a little bit, you see here when I close one tab and the user disconnects, you might want to show that they were around recently and they were last around for a few seconds ago. It wouldn't be possible to implement something like that with my crude logic here, but if you use a product like Spaces, that would be easy. And of course, you can wire up your own events here as well. The only thing I'm going to do, honestly, just to make this a little bit easier to follow along, is I'm going to log to the console that the user's disconnected. I'm also going to come up here, and apart from just logging the message, I'm going to log something more specific. With this in place, we're in a very good place to inspect how everything's working and just double check everything's all right before we go onwards to the React client, which I'm really excited to get into because a big focus here is how to use WebSockets with React, one of the most prevalent and nice to use front-end UI libraries out there and my personal favorites. Okay, I'm going to clear stuff up a little bit here and make sure I'm disconnected on both sides. I'm going to connect as Madeline and then disconnect as Madeline, and it should show that Maddie's connected and then disconnected. We'll reconnect. And then when I press send to update their state, we see a message log that says Madeline updated their state. And just for a quick sanity check, we'll connect here as Chloe and send a few more messages as Madeline just to make sure that we are getting the update and everything associated with it. Again, it's going to be so nice to be able to reference this object in JavaScript on the React side and do what we need with the data. All right, that's it for the server. Let's move on to the clients where things are going to only get more interesting. Okay, time to work on the React client. You'll remember that we made a tidy folder called server to house all of our server code. Let's now create a new folder called client, except rather than create it from complete scratch, we're actually going to use the npm create command, which allows us to scaffold applications using various modules without the need to install them globally. For example, we're going to use the Vite module and the latest version of it to create a new project inside a folder called clients. We can also pass an argument like this to specify the template, which is going to be React. The really cool thing about this is that it will bring in all of the necessary React modules, as well as some basic boilerplate that we would otherwise have to create from scratch ourselves. Let's follow the instructions on screen here and navigate into clients and run npm install. This will bring in React, React DOM, and a few other dev dependencies we may or may not be using. We're also going to use this opportunity to pre-install all of the modules I anticipate us needing to build the React client. The first is a module called React use WebSockets. The next is a module called lodash.throttle. And finally, we're going to install a module called perfect cursors. Now, I'm installing these up front so we can minimize the terminal and focus on the code. It's great for my tutorial here, but I'll explain these all in more depth as and when they come up. Just rest assured, because they're installed, we can now import them with ease. Just to make sure everything's working okay, while inside the client directory, I'm going to run npm run dev. Also, what's really cool about using Vite is that we get hot module reloading out of the box, so any changes we make in the code will be updated in the application without the need to reload the page. In other words, we can just leave this running in the background now for a little bit while we flesh things out. I think in time we'll start to peel away some of this boilerplate logos and text and things, but for right now, I'd rather focus on creating our first component. If you remember from the demo up front, the first thing we ask is for the user's username. So we should create a screen and a form to capture that. And as a reminder, we pass that username to the WebSocket server when we connect. So it's clearly a very important step. I'm going to create a new folder called components just to keep things nice and organized. And inside of that, a new file called login.jsx. I'm going to level with you. I personally always feel a bit weird in tutorials when they start pasting stuff. I like to see it evolve step by step, as I'm sure you do too. But since this is a long video all about WebSockets, and what we're creating here is quite a basic React form, I'm not going to type it all out or belabor it step by step. Nevertheless, we're going to want to see this login component in action. So inside of app.jsx, where there's actually quite a lot of cruft, I'm going to start chipping away at it right now. Like, we obviously don't want these logos in our real project. We're not building a counter application either, so we can remove this. And frankly, everything inside of these parentheses after return is superfluous, so we'll get rid of that as well. What we do want to do, however, is import the login components from components/login, and then we're just kind of seeing it in action here. It's not quite correct, but we want to just make sure it's imported properly. We can then return the login components, meaning that when we look at the browser and reload the page, we are prompted for a username. Now, it's kind of cool this is in the center, maybe, kind of, but whenever there's CSS pre-applied, I get the feeling like it might get in the way later. So for right now, I'm just going to remove app.css. It looks like probably there's some global styles coming from index.css as well that I don't really need. So I'm going to go into index.html and I think just comment out the CSS for a second. Oh, actually, it looks like it's probably imported in the main file instead, so we'll comment that. It looks a little bit ugly right now. We might refine this in a second, but this is how I want it. Apart from scaffolding the application, we could say that step 1 is creating and rendering the login screen. I guess that means step 2 is to somehow log in. And when you log in, you're going to want to see a different screen. In this case, we call this the login screen. When the user's logged in, we're going to show them a screen called home, which I'll create in a new file deliberately inside of source, not inside of components. Here, I'm going to export a very simple component that just returns the text home. This is purely illustrative at the moment. And then inside of app.jsx, I'm going to create a state variable called username. I'm also going to wire up here this onSubmit prop to the set username function returned by useState. Just to explain that quickly, when we submit the username form, this event handler is run. We prevent the default browser action, which is to basically reload the page as it sends off a request. We don't want that because we're handling it with some asynchronous JavaScript. And then we call the prop onSubmit with the username value. The signature of this onSubmit function matches that of set username perfectly, so we can just link them up like this. Now, here's the thing. App.jsx is the roots of our project. It's the first thing that gets rendered pretty much. And then it in turn returns and renders the login form unconditionally. But that's not really what we want to do. We only want to show the login form if the user hasn't submitted their username. This is really quite simple to achieve. First of all, we're going to import the home component because that's what we're going to want to render if the user has submitted their username. And then we'll comment out this return statement, commenting it because we can still reference it, but we don't need it anymore. And we can apply the ternary operator like this to say, hey, if the username is set, wow, great news. I want you to return the home component, please. If it is not set, then I would like to return, and we'll actually just copy it like this and then comment it. Actually, then I want you to return the login component. And by the way, hopefully I'm not moving too quick here when I say that, we actually want to pass the username to the home component because it's within the home component that we're going to actually run our WebSocket connection code. So of course the home component needs to know who is who. And we can, simplify, well, not simplify, sorry, but we can illustrate this a little bit. And instead of saying home, we can say hello and then, pass the username, for example, like this. That could be pretty cool. Let's test it out. We have a little error, which is that home is not actually inside of the components directory. So we just do it like this. And now when we enter a username like Alex and hit submit, it says hello Alex. And if we reload the page and say we connect as a different user, for example, Chloe, it says hello Chloe. Coming back to the code, believe it or not, we have almost everything we need to connect to the WebSocket server from the home component now. I think it's a good step to quickly run the WebSocket server. So I'm going to open a new terminal window, navigate into the server, and I'm going to run the index.js file and run the WebSocket server on port 8000. This is now running in the background. Yeah, we can connect to it from Postman, but we're beyond that now. We're in the React world and we want to connect from our React application. How do we do that? Well, something you should know about WebSockets is that they're not really specific to React at all. In fact, they're a built-in web browser API available in every modern web browser, very widely compatible. You can literally import WebSocket and access all these methods and functions. Here's a really good example of a vanilla browser API WebSocket in action. However, what we tend to do in the React world is we use a module called React Use WebSockets. Here it is on GitHub. The advantage of using this module over something like the browser API is twofold. First of all, the API is exposed via hooks, which is very idiomatic in React. It makes it very easy to know where and how to import the WebSocket connection. Bear in mind with WebSockets, you generally share one connection for all of the different types of communication in your application. You might have a lot of questions like where to put that connection, how to pass it around, how to clean it up a fish. This library takes care of all of that for us by exposing a hook called Use WebSocket. And by the way, I'm not sure if it's illustrated here well, but there is an option called share. And when you set share to true, what happens is the Use WebSocket hook will share share the same underlying connection no matter where you call the hook. So if you call the hook from different components or different instances of the same components, the use WebSocket hook can reuse that connection instead of opening a new one. And again, it takes away the burden of you having to worry about how to manage this connection. The second reason to use the use WebSocket hook is that it comes with some extra features that you're probably going to need. The thing about WebSockets as an API, especially this browser API, is that it's pretty minimal. That means it's super flexible and customizable, but the downside with a customizable protocol is that, well, it's custom. There's often a lot of work to do on top. For instance, something very basic you definitely need is automatic reconnection logic. Like if the client disconnects because the user goes under a tunnel, or the Wi-Fi disconnects, or they're connected on cellular and the cellular provider decides to reroute the connection to a different network master, for example, anything like that can happen and we need a way to reconnect. This module has a built-in option to enable that essentially, as well as some other handy, convenient APIs, like it has an enumeration for connection states. It's a mild convenience, but it also has things like last JSON message and send JSON message, basically allowing you to not have to think about converting things to and from JSON. Highly recommend this library when you're working with React. And you know what? We've already installed React Use WebSocket at the beginning of the video. So to access it, we just have to import it like so. You might be surprised at how quickly and easily we can use this hook and get connected to the WebSocket server. Inside of the component, in this case called home, we're going to call the use WebSocket hook. The first option use WebSocket takes is a URL to the WebSocket server, which as it happens, we have typed out already here. We're going to copy this less the query parameter, you'll see why in a second, and put that into a constant called WS, short for WebSocket, URL. We can then pass that constant to the use WebSocket hook. The second argument is an options object where we can set all kinds of options as described in the documentation. One of those options which you might need in your project is share. However, we don't need it today. The only option we need is the one called query params. And if you haven't guessed already, this enables us to pass the username as a query parameter to the server so that we may extract it and identify the user. In a nutshell, if we log in with a name like Alex, under the hood, what use WebSocket is going to do is append a query parameter with the same name as the object, in this case username, and then the value itself, right, which will be whatever we input into the text form. Use WebSocket returns an object with all kinds of goodies on it. You can see there's last JSON message, send JSON message. We'll use both of these in time, but for right now, we're doing this step by step. And the first step is to actually send the cursor position to the server. So here's a really key point in the tutorial where we've set up all of the WebSocket basics. We have the server running, we can connect, we have all our modules installed. The next two tasks, our final tasks, can be split in two ways, right? One is to actually send the cursor position. We'll do that first. Hence, what we're going to do here is extract send JSON message. That's all we need for right now. But later, we'll also want to subscribe to updates so we can complete step 2 here, which is to then obviously receive the updates and render everybody's cursor on the screen. By the way, if you recall, we installed this module called Perfect Cursors. That's going to come in handy a little bit later. I do believe that by virtue of calling use WebSocket, we connect to the server. So if I'm not mistaken, the client has kept reloading thanks to Vite's HMR. The server is still running as well, which means if I open up the client, and let's just put these side by side so I can see the server. In theory, when I connect, we should see that Alex is connected. And just like that, through React, we've connected with the unique identifier that's been generated. Headed back to the code, the next thing we need to do is send the cursor position. Now, the way we do this, first of all, is by calling use effect. Use effect essentially provides us with a way to execute some code the first time the component is rendered. We denote that by this empty array, essentially. We can pass the list of state variables to watch, and if they change, we run use effect. But in this case, when we pass an empty array, it basically translates into something like, hey, whatever code you put inside this block, just run it the first time the component is rendered, please. Don't keep rerunning it. And the reason why that's relevant is because here, we're going to add an event listener to the mouse move event. The The callback function passes an event argument like this, but we can access the client X and the client Y, aka the mouse X and Y positions. Every time we get the X and Y positions, we're going to want to send them to the server. However, there's a problem. I mean, the first problem is that we haven't imported use effect yet, so that could be a problem. So let's quickly import use effect. Let's also format the code a little bit while we're here. The second problem is a bit more subtle, not easy to spot right now, but it will become an issue later on. And that is the mouse move event could get fired a hell of a lot of times in not a very long period of time. Because if you have a high DPI or mouse sensitivity, and you're moving the mouse around, it could be firing off like thousands of events, maybe thousands every second, and then also sending that data over the WebSocket connection. Like, yeah, actually, to be honest, the WebSocket connection on localhost isn't going to struggle too much with that, but you have to consider the fact that probably if you're going into production, you're going to have like tens, if not hundreds, maybe thousands or tens of thousands. If you have tens of thousands of users, definitely use Ably. You do not want to be dealing with the WebSocket infrastructure headache that follows. But all of this is to say that obviously if you have multiple clients sending lots and lots of events, it's going to become a choking point really quickly. So what we want to do essentially is not send the mouse every single time it switches, but throttle it a little bit. And if that rings a bell, it might be because earlier on in the tutorial, we imported a module, or we installed a module, sorry, that we will now import called low-throttle. This is a really clever function. You can define, first of all, an interval, for example, every 50 milliseconds. And this says, hey, don't call this function that we're about to define any more than every 50 milliseconds. You could make it 1,000 milliseconds or 1 second and say, hey, don't call this function I don't care how many times you call it. I don't care how many times this event handler is run. Throttle the function. Don't let it run more than once a second. That's a bit slow. 50 is about the sweet spot actually, where you get a very smooth experience, but much better performance. What function are we throttling? Well, that's kind of up to us to define by calling the throttle function. And when we call the throttle function, we pass two things. First of all, the function to throttle, and then secondly, the interval itself, or how long to wait before allowing it to be called again and again. One way you can name this variable, and there's a few different conventions we could choose from, but I'm just going to call it send JSON message throttled and assign to it the value returned by throttle. Seemingly, we can now call send JSON message throttled with an object to send. This is the WebSocket message we're going to send with the X position, which will be e.clientX, and the Y position, which will be e.clientY. I say seemingly because there is a small problem here, which is that effectively this component, this function, is going to run every single time the component renders. When does it render? Every time something changes in the application state. How often does that happen? Literally every millisecond, more or less, with live cursors, because they're moving all the time. And what that means is that we'll be calling this throttle function essentially over and over and over again. And that's a bit of a problem because it's going to affect the internal timer and it's just not going to work as expected. If we want to hold on to a reference between renders and not keep recalling it, that's when we use ref. And so we'll import useRef. We'll wrap this up in a call to useRef. And by the way, one thing you should know about useRef is that whenever you wrap up a function like so, it doesn't just return the function, it actually returns an object with a property called current that represents the method that is throttled in this case. So we're going to have to slightly tweak this right here. Let's test this out. It should be visible. It should be demonstrable because on the server, we added some logging every time the user's state changes. So, and again, there's no need to reload here because Veach should have done it for me. I'll reconnect as Alex, and we're not reloading the server because nothing's changed. If I reload as Alex and I move the cursor, can you see how it keeps updating my state? It says Alex updated their state. And if we open another tab here and we connect to someone else, like Chloe, for instance, we'll see Chloe's connected and then their cursor position moves like so. If I flick between tabs, and it's kind of hard to illustrate on the same screen with the same mouse, but you get this idea now, hopefully, that the server is getting all of these updates. And what we can't see yet, but we're about to tap into is this idea that every time the server receives an update, it broadcasts everybody's cursor positions and their state to all the other clients. We can now subscribe to this in real time and update the page by rendering everybody's cursors. Well, I said we couldn't see this, but actually in Chrome, in the developer tools, if you make sure preserve log is ticked and you reload the page, you'll see all the requests the page made, including if we filter to WS, in other words, WebSocket connections, the connection is still open. So when we click on messages, it's kind of cool because when we log in now, you can see, here you can see the WebSocket connection. You can actually see the, kind of similar to what we saw in Postman, right? You can see us uploading the X and Y position. And what we get in response is this message with a snapshot of the most up-to-date state. It's true that the username Alex here is connected twice. That's just because of me opening two windows here. But if I disconnect even, we should see that updated essentially as we send out new messages. I guess they're at the bottom. Yeah, so now you can see it's just me connected. Anyway, the really cool thing is that this is here, this is ready. We're getting all this information without having to reload the page at all. That two-way connection is there. And now it's just a case of accessing that in JavaScript. There is just one tiny issue, though, as we embark on this part 2 of the two-part problem, one sending and one receiving and rendering cursor updates. It's just that if we are throttling the cursor update every 50 milliseconds or so, it's not a lot, but it will still create a kind of noticeable jumping, especially when you combine that, I think, with the natural latency incurred when you send something over a network. That's where the perfect cursors GitHub repository comes into play. What this library does essentially, and it's very clever and I like it very much, it plots the transition between two cursor coordinates, allowing us to animate the cursor and smoothly blend it, even though that won't be completely real time. I mean, in an ideal world, the cursor would update just as instantaneously as if it was the local computer, and it would be as smooth and buttery as the screen's refresh rate. But just due to the natural effect of the latency, that's not going to be possible anyway. Plus that delay, using a library like this is going to be really handy. And what I really appreciate is how they already have a React example. So what we can actually do is copy a lot of this into place. So just to summarize, we're going to set up this library in a matter of minutes, and then we're going to hook up our setup to the actual messages coming in to render cursors. So first of all, we need this cursor component. We're going to do this together here. Instead of components, we'll create a new file called cursor.jsx, and we'll paste the code. It looks like this uses TypeScript, so we're going to just remove the type annotations here. Next, we're going to create a folder called hooks, and we're going to create a new file called useCursor.jsx. Then we'll copy this hook and paste it inside of the file. Once again, I'll need to de-TypeScript this. It basically comes down to removing, I think, the type annotations. Like so. Next, we're going to go back to home.jsx. And do you remember how on the object returned by use WebSocket, we could access a few different properties, including last JSON message. This allows us to reference the most recently received JSON message. And it's really intuitive to use because it's very much the same as using a state variable in React, except every time we get a WebSocket message, this value updates, the component re-renders, and we can do some logic essentially. What logic do we want to do? Well, instead of saying hello username, what we're going to do is say if there is a last JSON message, because by the way, the first time the component renders, there won't be, not really, we're going to return a div. And inside of that div, we're going to call a function we've not yet defined called render cursors, and we're going to pass the last JSON message. We're going to declare render cursors at the top here because it's not really specific to the component, and it's going to take essentially the last JSON message, but we know, having looked at the shape of the message before, what it represents really is a list of users who are currently connected and their reflected states. So we're going to bring this argument a little bit closer to home with its name. And then we're going to return object.keys on users. Remember, because we use last JSON message, that actually takes care of turning that JSON string into an object, which in this case is kind of like a dictionary, right? Where we can call object.keys. And then we can map every single user that's part of that collection. We'll pull out the user like so. And then we're going to, first of all, import cursor from components/cursor. And then we will return for each user a cursor. We put a key, we use a key here to satisfy React. And then for the points, it's actually represented as an array, which will be the user, it will be the X, the cursor X, and then the cursor Y, like so, in a little pair tuple type situation like this. Something else we're going to do ever so quickly before we actually run the code now is, in addition to adding the event handler when we first render the component, I'm actually going to call send JSON message with a X and Y equal to 0. And the reason why I'm going to do that is because until we send a message, our WebSocket server isn't really pre-configured to know what's going on. So we're going to send this message off to just let it know that we're here and that we have a cursor. Very, very quickly after that, it will probably receive the genuine X and Y coordinates the second the user moves the mouse. The other thing this does, which is kind of handy, is, again, every time the server receives a message, it broadcasts everybody else's state. So this is kind of a cheeky way of asking asking the server to send everyone's state the second we load the component. Okay, that's maybe like 100+ lines of code without testing anything. So let's see what happens when we run the application. I don't think we need to, but I feel better by reloading. And there we go, we've got our first error. So component.jsx on line 4 is struggling to find use perfect cursor. Let's have a quick look at that. I guess because I did not call it use perfect cursor, I called it use cursor. And just like that, it seems to have reloaded, except we're missing our home screen, so we probably have another error. It turns out cursor.jsx does not provide a default export. I suppose what I need to do in this case is reference it by a name, like so. All right, okay, moment of truth. Let's see, we're gonna connect as Alex, hit submit, and it says React is not defined, not a problem. Let's go into use cursor now, and we'll import React. Okay, let's have a look. Oh my gosh. Okay, this is fun. It looks as though there's an error happening on line 20 of cursor. So let's go to 20. I'm not sure. I'm actually not 100% sure what's happening here, but I do realize that I've gone about this in the wrong way, because it should be import start as React from React. And I do just wonder if that might help. It looks as though we have another little bit of TypeScript here. I honestly can't tell you why that isn't just failing in JavaScript. That does not look like valid JavaScript, but I think it's possibly what was causing the confusion here. And check this out. You can see that as I move my cursor, I'm logged in as Alex right now. The cursor is kind of updated with that small delay under the scenes. And if we open another window like so, and we log in as, let's keep logging in as Chloe, for example, you can see that Chloe's cursor is right here, rendering in smooth real time as well. Just for fun, I've been curious what would happen if we go to home.jsx and we change the throttle to like a second. This could be kind of wild, but also, it's going to look terrible, I think, but it's kind of interesting to illustrate. So you can see that it only updates every second or so. So you've got that much bigger lag, but it's clearly more performant in the sense that you're sending less data over the network. But here's the thing, because of perfect cursor, despite the lag, it doesn't look jumpy, like it blends between those 2 points as and when we update the cursor position. The last thing I want to do here is a very quick thing, but it's to create a new function, which I'm going to paste in this case, called render users list. It follows very similar logic to render cursors, except instead of rendering a cursor for each user, it's going to render their application state in a list. To make sure this works, we're going to come to the return function here, and we'll call render user list. And without even having to reload the page, thanks to some Vite magic, you can see the user and their state. And check it out, if I connect as Chloe real quick, you should see Chloe connects, and if we close, it disconnects. The idea behind this essentially is that you should be able to create an avatar stack like this. Again, as I mentioned at the beginning, we have these interactive demos where you can copy the CSS if you like, but there might be a bit more work to do if you want to make it work really, really nicely, where like it shows that the user was recently online and not just offline or online in a very binary way. It's also the case that because here we're just dumping the state onto the screen, it works quite well. But if you wanted to do something in response to like a specific user disconnecting, or even detect which user disconnected, you would need to do some kind of diff on the two objects here. Or like when we touched on when building the server, you could raise some kind of event that describes the specific event of the specific user disconnecting. Well, there you have it, folks, a real-time live cursors example using React. In this video, we got to learn how to set up a WebSocket server using the WS Node module, and then on the client, we used a module called Use React WebSockets, or React Use WebSockets, in order to idiomatically manage the WebSocket connection. You can see here that this is a kind of contrived example. I mean, what you'd probably do in a real application, by the way, is hide your own cursor, but render the other person's. I think that would be a great next step to take. And of course, there's a lot you can do to make this look prettier. I'm making this video in collaboration with Ably, which is not something we've really spoken about today. It's a real-time experience infrastructure. Because it uses WebSockets under the hood, it's not unreasonable to think of Ably as hosted WebSockets. When you use WebSockets, there's a lot of complexity you have to deal with. I mean, here we're at a point where it's good for a demo, and it might scale to a reasonably busy production type of application, but there's lots of things you need to consider when it comes to real-time infrastructure, like how to maintain the lowest possible latency in a global application while preserving the highest degree of uptime, introducing redundancies. Yes, it's true that the React module for WebSockets can automatically reconnect, but you should ideally have a mechanism on the server to buffer undelivered messages such that they can be redelivered when the user reconnects and they have a seamless experience. And this is to talk nothing of this challenges scaling WebSockets. I actually have a whole video about that. The really cool thing when you use Ably is that you get all the benefits of WebSockets, but none of the headache. And it also has an idiomatic React hook available that makes it really easy to integrate into your React applications in general. I did make reference to Spaces, which is a product built on top of the core Ably infrastructure that enables you to build collaborative environments into your application. It includes features such as cursors and avatar stacks. In addition, other features you probably need, like user location, as well as component locking. It uses a very clever mechanism to make sure that two users can't accidentally overwrite each other's work. And because this all works with Ably, it's not hard to drop down a level and, for example, build real-time comments or a chat alongside this collaborative type experience. Of course, you can find the code on GitHub. And what I haven't really mentioned, by the way, is that this video is based on my complete guide to WebSockets with React, also created with Ably, where in addition to more or less this exact same tutorial, I share some core logic about how WebSockets work, as well as some best practices when using React and WebSockets together, such as where to put the connection. I'm personally a big favor of the use WebSocket hook, but there are other kind of patterns you can adapt that might be better suited for your precise application. I've been Alex Booker with Ably. Thank you so much for watching. If you enjoyed this video, please let me know in the comments, drop a like, and subscribe to the Ably YouTube channel, where we're going to be uploading more videos about WebSockets and how to build really impressive, engaging real-time experiences.